Grundig Heinzelman 1, 1954. This is the documentation of the experience of a hobby project, available in video and in written form, made with the hope that it could be helpful to others. But any comment that could help me to improve my practice is welcome and appreciated. This is one of the early European vacuum tube radios with FM. Like most of the cheap radios made in Europe after the early 1950s, it is enclosed in a plastic case. The original receiver included an electromechanical timepiece, which made it a pretty radio alarm clock. The radio was used, and in between the late 1970s and early 1980s underwent some significant repair and adaptation, which included the removal of the alarm clock that now is lost. The actual circuit structure is point-to-point, with very small components fitting a very narrow space, but built in layers. This structural choice is definitely unfortunate, making the repair of the radio very difficult. In fact, initially the radio was repaired keeping in place all the still working components and therefore avoiding a full electrical restoration process. Initially, also the alignment was not touched. When I was a kid in the late 1970s, I received this radio from a person living in a house near the apartment building where I was. I wasn't introduced to this person, but apparently he knew that I was tampering with old radios. He approached me when I was walking near his vegetable garden. He showed me the radio, asking me if I wanted to have it. Of course, I happily accepted the gift from this gentle stranger. I repaired the radio, replacing the components that were visibly damaged, using components recovered from old televisions previously dismantled. For instance, I replaced the missing knob for the tone control with a plastic shaft used to access variable resistors from the rear of television sets. The mechanical alarm clock wasn't working already, and I remember that I tried to fix it. It worked for a short while, but then I gave up servicing it and I removed it definitely because the radio is too compact and too hot. Removing the clock would have left a little more space for airflow. Unfortunately, after 2 moves and other common life events, the mechanical clock was lost. The truth is that I kept the radio only because it is relatively small. At the time of my first move, I had collected more important radio sets, which I had to give away due to the lack of space in my new apartment. Like all AM and FM radios, also this one has a complicated schematic diagram, due to the necessity to switch various parts of the circuit simultaneously. The schematics should be interpreted together with a guide to the variable inductances and trimmer capacitors used for the alignment. Online there is also available the description of the alignment procedure. However, for this unit, initially no alignment is attempted. Due to the way in which the radio has been built, it is impractical cleaning it except then using some pressured air. However, in the effort of finding the reason that was preventing the radio to return to life, this unit was washed in a dishwasher after removing the potentiometers. This practice is definitely not recommended due to the presence of exposed coils with very fine wires that would break just with the dishwasher water jets. With a lot of luck, nothing was damaged any further. However, the dirt and the dust were not the cause of the failure. The radio wasn't working just because of the selenium rectifier. Replacing it with a silicon diode brought the radio back to life. However, also a resistor should have been added in series to get the same voltage drop that the selenium rectifier had. Repairing the radio is meaningful only if the unit can be used then. Not replacing the capacitors that more likely have the chance to fail puts the unit at risk of severe damage. The fuse that is expected to be used is a slow-blow 300 mA type, but that would not give sufficient protection against those internal failures. On the other hand, if a lower current fuse were used, it would likely fail just when the radio is turned on or off, due to the initial or final current surge. Considering that the radio is capable of working at a slightly lower voltage, a small 60-watt light bulb is incorporated in the radio, putting it in series with it. If a failure were provoking an increased current absorption, the light bulb would become brighter and the voltage drop across it would increase, reducing the voltage available to the radio. The light bulb would be visible from the window formerly occupied by the clock. Also, the antenna connection requires some attention, but instead of using the original sockets, a new input is arranged, decoupled using safety capacitors. With this modification, there would be only a single antenna input for both AM and FM. However, this would be changed again 2 years later. In the original radio, the power on switch was part of the alarm clock, which is missing here. At this point, the radio was usable, even without any alignment, and the small halogen light bulb saved the radio a couple of times, once because of an internal short and another time because of a capacitor failure. The radio was put aside considering the project a failure, but 2 years later, this project was resumed. This radio, like other radios produced in particular in the 1950s in Europe, has the chassis directly connected to the mains. Even when the radio is turned off, but still connected to the mains, getting in touch with any metal part of the radio would imply an electrocution. In particular, in the event that a knob comes off, the power plug should immediately be disconnected from the mains socket. But also operating the radio with wet hands should be absolutely avoided. 2 years later, having learned to use hemostatic forceps for holding the components during the soldering and desoldering process, all the electrolytic and paper capacitors were finally replaced. This was done identifying the components first, matching them with the original schematic diagram. During this process, only one difference was noticed. The capacitor C39, instead of being connected to the filament of the tube EF93, was connected to the converter mixer tube ECH81. At this point, some study of the schematics seems to be in order. There are 2 antenna inputs, one for the AM and another one for the FM. The AM antenna input is isolated from the chassis ground with a capacitor. The two antenna inputs are coupled, unless this switch is turned to the position 5. Although it is not externally accessible, close to the antenna inputs there is also an extra connection point that is coupled with the mains so that the antenna signal could be taken from the power line. However, that connection would not be recommended nowadays. The power supply is based on an autotransformer, therefore the chassis is live. Like most of the radios with a live chassis, also this one has the power switch that goes to ground. In this area, there is also the clock, which was meant to operate with 220 or 110 volts AC without relying on the autotransformer for that. For this reason, the fuse holders were modified so that the clock would have been powered directly from the mains by the insertion of the fuse in the correct location. By the way, the power switch is meant to be part of the clock, and the same switch would be able to control a socket for powering an external device. The B+ voltage provided is about 260 volts, and the output power tube receives about 250 volts at the plate, which corresponds to its rating. Therefore, the B+ voltage should not be let rise above these values. The phono input deserves some attention. When it is activated, these switch terminals are connected. However, one should notice that the ground input is connected directly to the chassis, which is live, making this port very dangerous. Here is a comparison between the different configurations in which the radio could function. It starts with the long wave band selected. Medium wave band. Phono input. FM band. One may notice that the audio negative feedback from the loudspeaker is used for the tone shaping for all configurations except for the FM band selection. From the negative feedback the higher tones are removed, so that the negative feedback would subtract only the lower tones. Moreover, it is visible that for the FM, there is no automatic gain control active. The process of replacing paper and electrolytic capacitors was filmed only for two areas of the chassis judged more interesting. The first one is related to the filter capacitor area that is underneath the phono socket, which must be removed for accessing everything else. Once the filter capacitor terminals are accessible, they are cut, keeping the wires connected to them. However, reaching down there is very difficult, even with a mini wire cutter. The filter capacitor can is removed, but instead of restuffing it, the new capacitors are simply installed at its place, considering that the radio has been substantially modified already, having lost the clock and consequently its aesthetics. The white nylon washers are used to keep the capacitors slightly raised from the base. The positive terminals are shaped so that they could be used as posts, like the terminals of the original capacitor can. Finally, The two capacitors are kept together with some clear heat shrink pipe. When the electrolytic capacitors are connected and the paper capacitors of the area are replaced, the phono input socket can be installed again where it was. Unfortunately, it is held in place by four metal flaps of the chassis that must be bent back. By the way, the capacitor C50 is used here to isolate the phono input from the chassis. However, later this connection will be modified again, leaving the center blade socket disconnected. Behind the small antenna socket panel, there are two paper capacitors hiding in the corners. Both of them are very important for the safe usage of the radio, considering the presence of a hot chassis. In the previous restoration attempt, they were left in place. But because that was not safe due to the inevitable electrical leakage, other capacitors were added. This time, the original capacitors are going to be changed. Therefore, the additional ones are not necessary anymore. The new capacitors installed in this area are safety ones, rated 400 volts AC, and an additional one is installed, for extra precaution, in the link between the AM and FM antennas. All the final amendments will be shown in a later chapter. The radio is still working, and that is comforting. On a hot chassis radio, the chassis should be always connected to the neutral line, while the power switch should be inserted in the hot line. In this radio, this is not a problem because the original clock is not available anymore, and therefore nothing prevents from properly placing the power switch. However, this radio will be used in an environment with unpolarized power plugs. Therefore, an active buzzer will be used for sounding an alarm in case of incorrect power plug insertion. However, adaptation is needed and in this case a Zener diode is used to protect the buzzer from excessive peaks of the voltage. A small box is prepared for placing two fuse holders, the buzzer including its small board, and three sockets for halogen light bulbs. The two fuses are meant to protect each power line, considering that it is not predictable the orientation of the power plug. The three halogen light bulbs are meant to be connected together in parallel, but then in series with the input power line, with the purpose of dropping some voltage, considering that the radio was made for maximum 220 volts AC, but it is going to operate at 230 volts or even a higher voltage. To prevent the fuse holders from turning while changing the fuses, super glue is applied. With this modification, all previous modifications are removed, and the power cord enters now straight to this box. To install the box on the chassis, a small piece of iron sheet is placed on top of the space that formerly was occupied by the clock using a powerful soldering iron. The lid of the small box needs to be adapted to make space for the body of the fuse holders. The lid of the box is what is installed on the iron plate because the rest of the box will be just inserted on top. Initially, the box is meant to be installed flush with the surface of the iron sheet, but later it will be elevated to allow using zip ties to better hold the body of the box to the lid. Both power lines go straight to their own fuse. The external ground line will be used for testing the correct polarization using the buzzer. The power switch is connected to the front panel, and to allow an easy extraction of the chassis from the small cabinet, spade connectors are used. The output from the fuse on the hot line is connected to one end of the light bulbs in parallel. The other end will have to go to the power switch. The output from the fuse on the neutral line is connected also to a short wire that will be used for the buzzer board. The active buzzer is installed on the small box too. The buzzer board is connected. Later it will be insulated using a piece of heath shrink pipe. The small box is full as an egg. The box lid is fixed with pointed self-tapping screws. Some hot glue is used to cover them to avoid shorts inside the box. The two fuses are installed in their fuse holders and the box is put on top of the lid. Unfortunately, the power cord brings too much mechanical tension and the box pops out easily. Therefore, a couple of zip ties are used to hold the box in place. Finally, the two wires coming out of the box are connected where previously was the power cord. The new power cord will use the hole left by the missing output power socket after having removed the clock. For this reason, a small piece of iron sheet is shaped and drilled to cover that hole and to let the power cord pass through. To avoid the chance of getting in touch with the chassis from the corresponding large hole on the back panel, an insulation is made with some plastic sheet recovered from a vegetable basket. The power plug is adapted with an LED that would become bright if it is inserted with the wrong orientation. Later, this plug will be replaced with a slightly thinner one so that it could pass through the corresponding hole in the back panel. Here is the test. When the plug is inserted in the wrong way, the LED becomes bright and the buzzer goes off. The original selenium rectifier of this radio was replaced with a suitable silicon diode in the previous repair. Considering its exposed position, it seemed appropriate to also put some insulation. However, with a later configuration of the power supply, it was noticed that the first B+ voltage was too high, significantly exceeding the value of 260 volts. To bring the B+ voltage down to the required value, a resistor of 100 ohms needed to be inserted in series. For the purpose, the original selenium rectifier was modified and installed, insulating with care also the terminals. Before proceeding with the IF alignment, it is necessary to make sure that the cores can move without breaking them. There was an abundance of wax on the cores from the factory. For the purpose of removing that, it seems appropriate to warm it up, but the temperature applied must be controlled to avoid melting the delicate plastic tubes where the cores are inserted. Moreover, the heat should be applied as close as possible to the wax inside those plastic tubes. Therefore, the heat gun nozzle needs to be extended. Initially, it was used some heat shrink pipe. Later, a piece of fiberglass insulation sleeve proved to be more effective. The temperature chosen is not meant to reach the melting point of the wax, at least not with the quality of wax that was used by the factory, but enough for making it softer so that it could be gently removed with a plastic tool. According to the probe of the heat gun, the higher temperature used was 115 degrees Celsius. Once each core was able to move, it was turned in both directions with great care to make sure that it could travel freely during the alignment all along the space inside its coil tube. The alignment for this radio is described in detail inside the Grundig Repair Helper. For the AM/IF alignment, it is required to select medium wave from the band switch selector and to turn the variable capacitor at about 700 kHz. This document also suggests disabling one section of the IF transformer at a time, connecting the two terminals of that section to a 10 kilo ohms resistor and a 5 nanofarads capacitor in series. When the alignment starts from scratch, like in this case, having freed the cores by extracting and reinserting them, it is necessary to begin from the last transformer, injecting an AM modulated signal at the first grid of the EF93, the IF amplifier tube, and later injecting it to the first grid of the CH81, the mixer converter tube, for aligning also the first IF transformer. Please notice that the coils of the AM transformers share the same cans of the FM ones and must be carefully located before starting the alignment. By design, The IF alignment frequency for this radio is 468 kHz. For this unit, the method of disabling one section of the IF transformers at a time was not used, and the signal was read at the AGC line at this point, seeking for the most negative value. For this method of measurement of the signal, it does not matter if that is modulated or not, but the presence of the modulation allows a feedback also from the loudspeaker. Reading the voltage at the AGC line allows also to easily draw the bell curve upside down to evaluate the bandwidth of the reception, scanning the frequencies around 468 kHz. In this case, the scan was performed between 463 and 473 kHz. This radio model has also a wave trap that is meant to reject the frequencies around 468 kHz. It is necessary to apply the 468 signal at the antenna input, and the coil number 5 is to be tuned to get the lower output signal. After the IF alignment, the oscillator and antenna sections should be aligned with the dial, but that was not done because the reception was good and the dial scale of this radio model is not accurate anyway. For this unit, the FM-IF alignment was plagued by strange issues, which were only solved when, finally, a faulty coil was discovered. One thing that made the troubleshooting difficult is that in the area there are very strong FM signals, which easily make into the radio even without any antenna connection, and there is no way to cancel them, even disconnecting the FM tuner from the antenna or shorting it or using a passive load. The first issue that is worth mentioning was an internal oscillation in the area of the tube type EF93 at about 10.7 MHz. The signal was so strong that it was perceivable also across the electrolytic capacitor C52. Anyway, across the same capacitor C52, the DC voltage was below -20 volts. The oscillation was generated also removing the tubes EC92 and ECH81. Therefore, it could not be an external signal received and converted to the intermediate frequency. The internal oscillation was resolved only by extracting completely the core of the primary winding of the last FM-IF transformer, reinserting it then again later. When the signal was coupled directly to the tube EC92, or it was received from a regular station, the output was intermittent, but the effect of the intermittency was that the signal could be received clear or distorted, giving the impression that it was an issue of the discriminator coil. The issue was generated instead by the first IF transformer located inside the FM tuner. It was one thin wire of the primary coil that was defective already from the factory. As a matter of fact, this chassis was washed in the dishwasher, but no water jet could have reached into the FM tuner, so that could not have been the cause of the failure. The FM-IF alignment requires to select the FM band and to inject a 10.7 MHz signal in various places of the circuit. Generally, it is indifferent if it is modulated or non-modulated, except for the alignment of the discriminator, which requires an AM modulation. Initially, the signal is applied to the first grid of the tube EF92, and the last IF transformer is aligned. Then the signal is applied to the first grid of the tube ECH81, and the second IF transformer is aligned. Finally, The signal is coupled externally to the tube EC92, and the first IF transformer is aligned. This is contained in the FM tuner. In all circumstances, except for the discriminator alignment, the voltage across the electrolytic capacitor C52 or the resistor R20 is read, seeking for the most negative value. Here is the location of the coils for the FM-IF chain. Please notice that the discriminator is located at the bottom of the last IF transformer. In the Grundig repair helper, the alignment of the discriminator appears in the beginning, after the alignment of the primary coil of the last transformer. It is suggested feeding an AM modulated signal and finding the spot with the lower output signal from the loudspeaker. Before and after that sweet spot, the audio signal should be audible from the loudspeaker. Only for the second IF transformer, the Grundig repair helper suggests to disable the coil opposite of the one that is aligned. Using a 10 kilo-ohms resistor and a 5 nanofarads capacitor in series connected to its terminals. This was not done for the alignment of this unit, but the procedure was repeated for the two coils until there was no improvement anymore. At the end of each stage of the alignment, proceeding from the last transformer to the first, it might make sense to use a sweeping signal between 10.6 and 10.8 MHz to observe and verify the shape of the developing bell curve. At the end of the alignment, the shape of the curve should be smooth and not too pointed to allow the reception of a reasonable bandwidth. But this process is not easy, and there are no instructions on how to obtain that. Even if the discriminator is tuned properly, if the bell curve is not shaped well enough, the sound reproduced would be distorted anyway. Therefore, while experimenting with the shape of the response curve, it is also important to test the quality of the reception and try again if that is not good enough. The loudspeaker and the speaker panel are removed from the cabinet. Also, the brass frames and the dial lenses are removed. The old grill cloth is removed from its panel, and a new fabric is glued on. The brass frames are polished using fine steel wool with a metal polish product. The residues are cleaned with a cotton ball and alcohol. Later, the frames will be sprayed with clear lacquer, but off camera. Also, the knobs are polished and then cleaned with alcohol, brushing them with an old toothbrush. The cabinet is polished using some red oil. Before that, the push buttons were removed from the cabinet and cleaned too. The clean push buttons are mounted. The brass frames and the dial lenses are mounted again using nylon washers in place of the original consumed felt washers. Also, the power switch is mounted on the cabinet using one of the holes left by the clock mechanism. The grill cloth flaps that exceed the surface of the speaker panel are cut or burned off with the soldering iron. The speaker panel is mounted first on the cabinet, then the loudspeaker is mounted on top of the panel. There are two holes on the back panel that it is better to cover to avoid getting in touch with the chassis and to dissuade in using the phono input, which originally had a terminal connected to the chassis with no isolation. The original clock is lost, and the corresponding empty dial makes the look of the radio somehow sad. This radio also lost the original Grundig writing in front of the cabinet. A thought was given to cover the empty dial with a reproduction of the name Grundig that was lost, but there is no clear example on the Internet, and if there were it would appear particularly reduced in size. I have a friend who, besides having valuable professional qualities, also has a very beautiful handwriting. I asked her to write on paper various examples of this name, and with one of them it was possible to draw a decent cover for that blind dial. That was printed on a thin, light yellow cardboard, and here is the process for placing it properly behind the empty dial. Before inserting the chassis in the cabinet, it is necessary to push down all the 4 switches on the front. The original fuse is still in circuit. The polarization of the chassis is verified when the power plug is inserted correctly. There is a very little voltage differential between the chassis and the electrical ground. If the plug is inserted the other way round, the buzzer goes off and the chassis has an elevated voltage compared to ground. After installing the knobs, the screw holes are covered with wax for extra safety. Here is the final schematic diagram for this modified item. The most important changes are located in the power supply area where 2 fuses have been added. A buzzer is used to sound an alarm if the power plug is inserted in the wrong way. 3 halogen light bulbs in parallel are used to drop the excessive voltage from the mains. The selenium rectifier was replaced with 2 silicon diodes in series and 2 resistors in parallel. The power switch is now located in the hot line. The space over the band switch selector is now covered with a piece of plastic, recovered from a vegetable basket. Here is a last view above and under the chassis. Here are the components and parts that have been replaced. The test is done in the evening using an indoor antenna, and it starts with the long-wave band. Unfortunately, at the time of this reception test, there is still too much electrical noise produced in the building, and no station can be heard in this band. Medium wave band.
Române și vă aștept alături de mine în această luptă. Wakeford to sort the trouble in this group. It's only 3 away wins in 17. Rory McCormick makes his full debut. En Europa es pactar con lo que llaman la ultraderecha europea. Para las líneas rojas
Melodie, Mirka Milic, Jadranka Šuligoj ter Marta in Savina Valetič.
FM.
Cadoro.it. Cadoro, verso la convenienza.
Ogni anno presenta un focus.
Compositori di punta negli Stati Uniti in questi ultimi anni, davvero
Immagina adesso casa dei generali, proteggi ciò che ami anche da vento grandi e altri eventi atmosferici. Contatta subito i nostri agenti.
Non farà chi è? Olimpionico, che era andato a fare jogging.
Se sognate una vita felice, imparate da più. Uno torce, un giorno piccante. Così non mi annoia.
adesso quando sono le 20, 26 minuti e 16 secondi è il momento di passare il nostro cartellone.
Sono Orogel, sono pronto ad essere il tocco di gusto alle vostre ricette. Pronto a darvi il più. Sono le verdure più buone.